This is our third video graphing polar equations, and in this video we're going to graph what's called a Rose curve. The graphs of r equals a times sine of n theta and r equals a times cosine of n theta, where a is not equal to 0, are called Rose curves. If n is even, the rose has 2 times n petals. If n is odd, the rose has n petals. Like with all of our polar graphs, we're going to start by testing for symmetry, hopefully to limit the number of angle thetas we have to put into our theta r chart. We're going to test the polar axis, the line theta equals pi over 2, which coincides with our y-axis, and then the pole. When testing for polar axis symmetry, we replace theta with negative theta. When testing the line theta equals pi over 2, we replace both r and theta with the negative. And then lastly, with the pole, we're replacing just r with the negative. Remember that we will be using our negative angle identities. Cosine of negative theta is equal to just cosine of theta. So we want to keep that in mind as we're testing this symmetry. Testing the polar axis, we're replacing theta with negative theta. That gives us r equals 2 times cosine of 2 times negative theta. And we know 2 times negative theta is going to be negative 2 theta. Here's where our negative angle identity comes into play. Cosine of negative 2 theta is the same as just cosine of 2 theta. This is our original equation back, so yes, the graph of this will display symmetry with respect to the polar axis. Testing symmetry with respect to theta equals the line pi over 2. We're going to replace both r and theta with the negative. So this will be negative r equals 2 times cosine of negative 2 theta. Applying our negative angle identity, we know that cosine of negative 2 theta turns into just cosine of 2 theta. This is not our original. We could try dividing both sides by a negative, but that's still not going to get us back to the original. So it's inconclusive whether or not we're going to have this type of symmetry. So that's a maybe. And then lastly, we're testing symmetry with respect to the pole, where we're replacing just r with the negative. This is not the original, and there's no way for us to turn it into the original. Dividing by negative 1 isn't going to get there. So this is another maybe. The only kind of symmetry we can count on is symmetry with respect to the polar axis. Remember that the polar axis coincides with the x-axis, so we either need to do quadrant 1 and 2 or 3 and 4 when we're doing our theta r chart. I chose to do quadrants 1 and 2, so you'll see that my chosen theta values range straight through from 0 to pi. And I found all the corresponding r coordinates. Remember, all you need to do is plug it into your calculator by plugging in each one of these theta values to get the corresponding r values. Well, let's plot some points. Starting with our angle 0, we're going to go out 2 rings. At pi over 6, we're going to go out 1 ring. At pi over 4, we go no rings, so at the origin, at the pole. At pi over 3, we're going to go -1 rings. So remember, when your R value is negative, you go in the direction opposite of your angle. So we're going 1 ring in that opposite direction. Next up, we have pi over 2. We're going out 2 rings. At 3 pi over 2, again, we have a -1, so we're actually going to go in the opposite direction. 1 ring. At 3 pi over 4, we're going 0 rings, another point right at the pole. 5 pi over 6, we're going out 1 ring. And then last but not least, at pi, we're going out 2 rings. Okay, so those are our points from our chart, but we know that the graph of this displays symmetry with respect to the polar axis, which coincides here with the x-axis. So as I look at this, I definitely do not have the mirror image top and bottom, so I'm going to reflect some points about that polar axis. And I'm just going to start on the left and work my way right. So this first point's right on the polar axis, nothing to reflect. But this point here, I'm going to reflect, and I'm going to get another point right here. If I reflect this next point up, it's going to be right here. The point at the pole is going to stay there, but this point up here is going to reflect down. Our next point here, I'm going to reflect up. Comes right here. And reflecting this point down, I'm going to get another point right there. Okay, so this graph is supposed to resemble a rose, but I feel like that word is used very loosely. This looks like a flower that you would have drawn when you were, 5 years old once we get them in. Basically, we're just drawing petals. So here's our first petal. Our second petal. Our third petal. And our fourth petal. Remember, in our definition, it said if n, which is the number multiplying theta, in the argument of our equation, is even, then the rose is going to have 2 times n petals. So we get 2 times 2, 4 petals.